Suppose the annual demand for wine at a wine shop is 900 bottles. It costs $1 to store 1 bottle of wine for 1 year, and it costs $5 to place an order for wine. How many bottles of wine should be ordered in each order to satisfy the demand and to minimize costs? We'll need to take into consideration the two different costs in this problem, the reordering cost and the storage cost. We'll assume that each order will have Q bottles of wine in it. Now let's look at some specific examples. We could order all 900 bottles in one single order. The reordering cost would be $5, and the storage cost would be the average inventory of 450 bottles times the cost to store for 1 year. This leads to an actual cost of 5 plus 450, or $455. An order size of 450 leads to reordering cost of 2 times 5, since 2 orders need to be made, and storage cost of $225. This leads to a total cost of $235. Let's put these values into a table with the order size, reorder cost, storage cost, and the corresponding total cost. Notice that as the order size drops, the reordering cost increases and the storage cost drops. If each order contains 225 bottles, the 4 orders cost $20 to order, and an average of 112.5 bottles are stored throughout the year, yielding a total cost of $132.50. We can continue to reduce the order size to see the total cost continuing to drop. However, for very small orders, the total cost begins to creep up. For an order size of Q, the reordering cost is 900 divided by Q times 5, and the storage cost is Q divided by 2 times 1. The sum of these costs is the total cost. This can be simplified to yield the total cost function, 4,500 times Q to the negative 1 power, plus 1/2 times Q. Set the derivative equal to 0 to give a realistic critical number of approximately 94.87. The second derivative can be used to determine whether the critical number is a relative maximum or minimum. Since the derivative is positive at the critical number, it is also a relative minimum. However, distributors do not appreciate order sizes with decimal amounts. Realistically, we order either 94 or 95 bottles in each order. If we evaluate these order amounts in the total cost function, we see that an order size of 95 is cheapest. A graph of the function verifies these numbers.